Mr. Luneski here today with the last section of Unit 2 already. Oh my goodness. We have parallel and perpendicular slopes. So some of this is actually a little bit of a review from algebra, nothing too earth-shattering and new in this section. So just a little bit of an algebra review. So, for example, if we had these two graphs here, it says find the slopes of the two given lines below. Just as a reminder, when we are finding slope, we are essentially counting rise over run. And rise can go up or down, and run, we typically always run to the right. So we read a line like we would a book from left to right. So when we are finding the slope, we essentially are just looking for some points on the graph. So let's count this slope. I go down, let's see, there's a line here. So I would go down 1, 2, 3, and then over 1. So -3 over 1 technically gives me a slope of -3. If I look at line B, I go down 1, 2, 3, and over 1. And hey, those are the same slopes. So sort of what we have here from this example, we can determine that the slopes of parallel lines are going to be the same. These two lines, A and B, would be considered parallel. Over here, we have the little 90-degree box here indicating that these lines are perpendicular. So let's take a look at the slopes of these two lines then. Line C has a slope of, let's see, if I go down 1, 2, and over 1. So down 2 and right 1 gives me a slope of -2. And the slope of line D, here's a point. I go up 1 and right 2. So up 1 and right 2 gives me a slope of 1/2. So my slopes here are -2 and +1/2. So what can we say about slopes of perpendicular lines? We can say that slopes of perpendicular lines are opposite reciprocals of each other. Opposite reciprocal, remember, just means that we're essentially flipping this as a fraction. So 1 over 2 becomes 2 over 1, and then opposite means that we're changing the sign. So it becomes -2 over 1, or just -2. So, moving on, we have a little postulate here about the slopes of parallel lines. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Why two non-vertical? Because if you recall, vertical lines have undefined slope. So if you ever see that pop up, a vertical line, remember it has undefined slope. Horizontal line has a slope of 0. Any two vertical or horizontal lines are parallel. So if I have two horizontal lines, they're automatically parallel. If I have two vertical lines, those are automatically parallel as well. Slopes of perpendicular lines. In coordinate planes, two non-vertical lines are perpendicular if and only if the product of their slopes, product means multiply, if the product is -1. Horizontal lines are perpendicular to vertical lines. So if I have a line with a slope of 0 and a line that is undefined, those would be perpendicular. So that's just saying if I multiply the two slopes, it would equal -1. So here's some quick examples of, given a slope, what would the slope parallel to it and perpendicular to it be? So my first example here, we have 3/5. So the slope that is parallel to that, parallel slopes are the same. So this would also be 3/5. Perpendicular slope, that's when we flip it and change the sign, opposite reciprocal. So when I flip 3/5 as a fraction, it becomes 5/3. And then I just change the sign. So it was positive, now it's negative. A slope of 0, parallel slope stays the same. Perpendicular to a slope of 0 is undefined. So remember, 0 is that horizontal line. Perpendicular to that would be a vertical line. Vertical lines have a slope undefined. 1/2, parallel to 1/2 would be 1/2. Perpendicular to 1/2 would be -2, or -2 over 1, but we typically don't leave it like that. We just write it as -2. Flip it and change the sign. And then the last one here, -6, parallel slope, -6. And then as a opposite reciprocal of -6, that becomes 1/6, positive 1/6. Okay, on the back we have some examples here determining if the lines are parallel, perpendicular, or neither. So remember, parallel means they would be the same, perpendicular means they would be opposite reciprocal, and neither would be if none of those scenarios come out. So just as a friendly reminder, we're really just finding the slope. So my formula for finding the slope, y2 minus y1 divided by x2 minus x1. So really we're just finding the slopes of these lines. So I'll do -1 minus 2 divided by 0 minus -2, which is 0 plus 2. So this is for line 1. So -1 minus 2 is -3. 0 plus 2 is 2. So the slope of line 1 is -3/2. Line 2, now I'm going to find that slope. So 3 minus -1, and then 2 minus -4. That gives me 4 over 6, which, as a fraction, simplifies to 2/3. So if I compare these two fractions, they are not the same, therefore they wouldn't be parallel. However, these are opposite reciprocals, so these two lines would be perpendicular to each other. Example B here, x equals 5. This is the equation of a vertical line. Y equals -3 is the equation of a horizontal line. So we mentioned it earlier, if we have a vertical line and we have a horizontal line, that those slopes are going to be perpendicular. So I'm going to have you do these two problems on your own, just to kind of try that out by yourself. Take a look at these two example problems here. Line M passes through -2, 4, so I'm going to graph that point. -2, 1, 2, 3, 4. And -5, 1, 2, 3, 4, 5, 1. So that's the line M. It says graph the line parallel to line M that passes through the point 0, 2. So just graph the point 0, 2. And now we need to draw a line that's parallel to that. So remember, the key here is that if it's a parallel line, the slope has to be the same. So just go ahead and count the slope of this line, and then we're basically going to mimic it and draw our new line. So here we have up 1, 2, 3. And then over 1, 2, 3. So we can sort of just continue that pattern. This ends up being a slope of 1, but we can still go up 1, 2, 3, and over 1, 2, 3. And this is sort of what that line would look like. Parallel line. The next example is kind of the same thing, but instead of doing parallel, now we're going to do perpendicular. So we have a line passing through the point 1, -2. And 5, 6. 1, 6. So here's my line. We call that line H. Now we want to graph the line perpendicular to line H that passes through the point 2, 5. So 1, 2, 1, 2, 3, 4, 5. And we need to make perpendicular. We need to draw a line so that these are perpendicular. So once again, we're going to count the slope. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. And to the right, 1, 2, 3, 4. So we went up 8 and right 4, which gives us a slope of 2. In other words, we were going up 2 and right 1. So perpendicular to 2 over 1 would be -1 over 2. So that's what I need to do from this point. Go down 1 and right 1, 2. Down 1 and right 1, 2. So when I draw this line, Now they're perpendicular. Parallel slopes, slopes the same. Perpendicular slopes, opposite reciprocal. All right, and then this last little section's pretty quick. The distance from a line. The distance from a point to a line is the length of the perpendicular segment from the point to the line. The perpendicular segment is the shortest distance between the line, between the point and the line. So if you look at this first problem, it says the distance between Q and RS is, well, here's point Q and here's line RS, and if you notice, we have two segments that are being drawn to RS. So both of those are technically segments that go from Q to RS. But when we ask for the distance, we want to know what's the shortest possible distance. So if we look here, we want the perpendicular segment. So that would be 4. So now this one's saying the length of which segment shown is called the distance between X and line K. So this is line K, here's X. Which one's the distance? That's where our perpendicular line is. So we would call that XV. And then finally, we have the length of which segment shown is called the distance between the two parallel lines. So here are my two parallel lines. Which of these gives me the distance? That again, we look for that perpendicular part. That would be segment AB. Forgot my little segments. Okay, that is all for today. Thank you for watching.